Okay, so this is what's my function, page 1. Should have this thing out. You take a look at it. Part 1, function contains only these 5 points, and a list them here. Okay, that should give this away as being a discrete function, but the first thing we're going to do is plot them. There's 1, 0, -1, 1, -3, and 2, -5. Okay, we are not going to connect these because it says that it contains only these 5 points. So that means that this is discrete. The next thing, is this thing increasing or decreasing? Well, as you can see, it's going down, so this will be decreasing. Our y values are going down as our x values are going up. So the domain, okay, this is discrete. So we only have to list the x values, which will be -2, -1, 0, 1, and 2. Range will be just the y values, which will be -5, -3, -1, 1, and 3. Listing these things out going from smallest to the biggest this way. So what equation is going to relate these things? Okay, so what they're asking then is, if we fit a line through this thing, what would that be? All right, well, let's take a look. There's your y-intercept. So it's going to be some number times x minus 1. And so now we need to go in and find the slope of this thing. Okay, it's going to be rise over run. So I'm going to go in and pick. I've got some points here, so I'm going to go up 2. I'm going to go to the left 1, so it's going to be -2/1, which is a -2. And that is my slope. Okay, so what's the domain of, when they say representative equation, they're talking about this thing right here. So the domain of my line is all real numbers. We know that because it keeps going on and on forever. However, the domain for my problem situation, that's for the equation, the domain for my problem situation, which is up here, is only 5 points. So it's just one small part of what the equation is. Okay, so let's move down and take a look at problem number 2. So here you come back in. You notice that they're going to charge $29.99 per month, so that's a flat fee. And then they got 12 cents per minute, or a portion of a minute. So let's come in, we need to write an equation. So that's going to be y equals, all right, we're going to add that at the end. And we've got 12 cents per minute. This right here should key you that you're dealing with a minute. So it's going to be converting that to dollars, 12 cents is 0.12 times minutes, which is X. And there's your equation. So is this function increasing or decreasing? You can tell this without even graphing it. Your slope's positive, it's increasing. Because slope is positive. So the function itself, and here they're referring to this equation. The equation itself is continuous. Now the problem situation, take a look at it up here because it's just a portion of a minute. The problem situation is discrete. So the domain, all right, well, let's take a look at this. Here's my X. And there are a couple of ways you can write this. Now I know we can't have negative minutes, but we can have 0 minutes. Now I can have a portion of a minute, because if you talk for 1.1 minutes, they round it up to 2. So you need to come back in. So the domain, and there are 2 ways you can write this, will be all integers greater than or equal to 0. Or you can write it this way. And it's going to go on off forever up here if you talk too much. So how do the domain and range differ from that representative? So the domain of the problem is only positive integers. Whereas the domain of the equation is all real numbers. The range is the same idea. The range, we haven't done the range, so let's do that up here. Now the range up here, if we put in 0 for this, this number goes to 0, but we left for that. So the range is going to be y values that are going to be bigger than or equal to 29.99. Whoop, wrong place. Y values bigger than or equal to 29.99. Because even if you don't make any calls at all, they're still going to charge you this amount of money. Okay, so the domain then of problem is only numbers larger than 29.99. Excuse me, that's the range. The range of the equation is going to be all real numbers. So again, the range of our problem set is just a part of the range of our function, and same way with the domain.